So I have this toy. It's, I think for kids, you put these like colorful blocks in holes, and I can't quite figure it out. Can you pull me up a figure that demonstrates how I might solve this problem, please?
Sure thing. Let me find a figure that might help you with that.
Gotcha, gotcha. Very cool. I feel super smart now. I think I want to get into investing. Hey, can you pull me up a figure that shows the portfolio overlap of the S&P 500, please?
Sure thing. Let me find a figure that might help you with that.
Cool, 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 cool. Hold on. I got to get back to work. Hey, I have a package that's shipping LTL. What testing protocol should I follow?
I'll find the relevant figure for the LTL shipping testing protocol for you. From the document, if your package is shipping LTL less than truckload from the fulfillment center, you should follow the ESTA 3B protocol. This is indicated in the flowcharts and guidelines provided for packaging testing requirements.
All right, fantastic. So we're going to be talking about that. If you're interested in building something similar to this using documents to power complex LLM-powered applications, you came to the right spot. Roll the intro.
Hello, everybody. Welcome once again to another episode of RAG Masters, a show about, yes, retrieval augmented generation. I'm Neil Katz, your host, a 20-year tech exec. With me, as always, Daniel Warfield, data scientist, RAG engineer, educator extraordinaire, and here to talk about something very cool today, Dan. You are messing with voice commands, which is the latest hotness. The ability to build RAG applications with complex documents and be able to control them with your voice instead of your hands. And I think there's just huge applications for this. You've done some fun ones, which we will talk about, and you're going to show us how it gets done. But when I think about the ability to, for field mechanics to be able to talk to an AI that tells them how to fix machines in the field, whether that be, I don't know, building machinery, facilities, or even your car, stranded motorists trying to figure out how to fix something, that sounds unbelievable to me. When I just think about all the busy things we do, a lot of the time we don't not in like GPT chat mode. Voice could be really, really powerful. And I think the thing I love, and you're going to show us today, the thing I love about it's not just voice, which we've seen other people do. We've seen people just play with OpenAI's new voice models, but it's voice with RAG. So we're pulling up relevant documents, not just talking to OpenAI's model. And then the interface is kind of cool that you've done, because again, it's just not really chat-based. It's like you ask questions and it shows you relevant pages from documents and knows where to go in a way that seems really actually intuitive and useful. So I want to let you pull back the curtain, explain to us today how you've done some of these really cool magic tricks, and maybe show the audience how they can do them too.
Yeah, it's cool. It's Brave New World. Pull up the slides. Let's get into it. So it's like, hey, Jarvis, Claude, they just released, I think yesterday, this new like interface with interacting with your computer. We're breaking out of this. It's just a chatbot thing. And this is, I think, one example of the many ways you can do it. So this demo, it's a proof of concept demo, and it's running in Vue and Flask. Basically, from like a super high level, the Vue is it's in charge of the front end, kind of like just rendering, playing audio, whatever. We're mostly going to be talking about Flask, which is Python. And if you wanted this to be productionalized, you might use Fast API, whatever. But this is the thing that's, doing the processing, calling the LLMs, all the fun stuff. So we're mostly going to be living in the Flask side.
Okay.
So, what is the demo? The demo is I talked, and then it did some stuff, and then it responded to me, and it like rendered a PDF. So you might imagine that there's just, and I kind of want to clarify this before we really get into it. You might imagine it's just one back and forth. You take the audio, you send it to the backend, it does some processing, then you spit back like, I don't know, like a PDF and some audio playback. But you'll notice there's a lot more back and forth. And the reason for this is because within the time constraints, I didn't do everything under the sun I could have done, but I wanted it to feel somewhat snappy. So there are several opportunities for the model to respond verbally throughout its processing process so that it can feel a little bit quicker and you don't have to just sit around and wait forever.
Okay.
So with that said, there's going to be some stuff that we calculate in the beginning and then pass it sort of towards the end. We talked about agents as directed graphs, I think, with like a LangGraph and stuff like that. This is an emerging sort of idea, is when you're adding an LLM to an application where you have a lot of state that's passing back and forth, there's a lot of coming up with linguistic concepts and then saving them and then using them later. So we're going to be sort of adopting a similar approach in this sort of application.
Yeah, that sounds really cool. But there's more here than just Vue and Flask, right? What actually is the full stack of tools you've used here? Those may be some of the newer ones we're playing with, but I know you have other tools in this stack.
Yeah, I probably should have put this earlier. So it's Vue and Flask that's running like the big picture, but within it, we're using the new Whisper API by OpenAI, which is speech to text and text to speech, which is super cool. We're also using LangChain's relatively new as structured output to help us with processing responses and organizing them and parsing them so that we can use them programmatically, which we'll get into. And we're also using our RAG tool, GroundX, to actually do the retrieval.
All right, so you've got 5 layers to this stack.
Yeah,
it's Vue doing the front end. You've got Flask sort of containing the application logic. You've got OpenAI's Whisper handling all the voice components. You have LangChain, actually LangGraph, I think you're using to clean up some of the content moving back and forth. And you've got GroundX as the RAG APIs handling the document ingest and search and retrieval under the hood.
Yeah, I am actually using LangChain technically. LangGraph and LangChain, they kind of exist. I'm using tools from LangChain that I think are used to power LangGraph, but I'm not using LangGraph explicitly. You could, though. You totally could use LangGraph, and probably with great effect.
Okay, great. All right, let's proceed then. How do we get this built?
Yeah, all right. So first step, kind of the most, maybe the simplest one. It's cool. Whenever you use an OpenAI model, it's always this multi-billion-dollar crazy AI stuff, and then it's like 4 API calls. I think that's part of the reason they're so popular, besides the fact that they're capable. It's just super easy. You have this simple API where you take pre-recorded, sorry, I want to make sure my phone's off. You take pre-recorded audio, and you pass it through this simple API, and it gives you a textual transcript. And that's basically it. That's all you have to know as a developer.
Now, is this different than OpenAI's voice model that came out to great acclaim just a few weeks ago, and they put out all kinds of cool demos of people interacting directly with the LLM?
I think so. Yeah, I was digging through the Whisper API because I was expecting like, okay, how do I talk with the AI model? When I was like building this, I was like, that's kind of, you assume based on those demos.
Yeah, it was like a voice native model was the pitch. The pitch was it's not actually going to text, it just understands voice, and it doesn't have this translation from modality to modality in the middle. But it sounds like for you to actually make something useful of it with RAG, you maybe had to use a different piece of their stack that they offer people.
So I poked around and I looked. I didn't find this voice to voice native modality. When you look at Whisper, it's speech to text and it's text to speech. Maybe I missed something. Maybe they have a completely different product offering that I didn't see. But I poked around for a while. I didn't see it. I feel like it'd be right at the front end. I think that they're slowly rolling out this additional functionality. I think they demoed this very cool model a while ago, and I think they're using it internally for some of their own stuff. And I think you can use it in chat maybe, but I imagine like the application development around that's kind of complicated. All of this is moving so fast. I imagine they'll be incrementally rolling out features like that as the models mature and as the APIs that they're developing around them mature. But yeah, I use the speech to text and text to speech, which is actually really great because if you don't need to go, hey, am I happy or am I sad? Like if you don't need that type of functionality, you can really leverage the simplicity of a textual modality with very little negative side effect.
Yeah, for sure. And this is, this Whisper has been available for some time, but now we're getting to show how you can do really cool stuff with it that actually, I think, mimics some of the fancy pants of the recent demos from OpenAI, but actually makes it even more useful.
Yeah, absolutely. So behind the scenes, I just want to kind of cover this really quickly.
Yeah, let's see.
I have slides up. So the Whisper, it's actually, we don't have to get into the AI, but I thought this was really freaking cool. So we used to have, for the AI nerds, we're going to be on this slide for like 5 seconds. So if you don't know what I'm saying at all, no big deal. But they've been doing this sort of ChatGPT style decoder only transformer. This Whisper style model, it seems like it's very similar to the original transformer, except so you have this encoder on the left and this decoder on the right, which is very similar to the original transformer with the encoder and the decoder, except they're using what's called a MEL spectrogram, which is frequency content from video instead of a textual input. And then they're using that to encode the voice input and then use it with cross attention to do auto-regressively generate text, which is behind the scenes how this model, using all this fancy AI magic, is just going ahead and taking my audio file and turning it into a textual transcript.
Okay, very cool.
Which is cool if you're into that. And if you're not into that, then doesn't even matter because you can just call the API. Just send it an audio file and you're good. So now we get into really the meat of like what I built, right? So we have this textual transcript from Whisper. And then what I decided to do, there's a million ways I'm sure you could do this. I decided to first come up with a plan of action. So on the front end, there's certain things that my front end that I'm developing can do. It can, find a specific figure. If you can see this at the very top, I have this object here. It can find a figure. It can find a PDF. It can maybe scroll up or scroll down or snap to specific pages.
Oh, that's cool. Because you didn't show us that. That would have been neat if you showed voice commands for going around the document. That's pretty cool.
Yeah, and I don't think all of them are wired up. I think I ended up doing the page snapping. I implemented that. But so like you have these different things, and you can imagine a lot of them, right? You can imagine all sorts of application related things. And what I'm doing is I'm structuring those as an object. Here it's just a bunch of bools, but it could be strings and ints, whatever. And then I'm defining a system prompt for the language model. And I'm describing what I want these things to behave, right? Like what is snapping to a page? What is finding a figure? So I'm using the system prompt along with this object. And I'm using LangChain's as structured output. And basically what as structured output does is it takes your prompt and whatever your query is, and it wraps it around another prompt that gets the language model to construct a formatted output. And then LangChain automatically turns that formatted textual output into your code. So it turns it into an actual object in Python, which is really useful if you're developing applications, because then you can use language models to make programmatic decisions and use them in a fairly robust manner. So the query, hey, can you pull up a figure of the portfolio overlap of the S&P 500? What I'm doing here is I'm passing that to this prompt, and then as structured output is making a binary decision of, are we looking for a figure? Are we looking for a whole PDF? Do they want to scroll up? Do they want to scroll down? Et cetera, et cetera.
Yeah, I mean, what's interesting here is this is, this is basically an if-then else statement, statement here. But instead of writing it in code, you've literally written it in English.
Yeah.
Of course, the language models speak English, and so it's fascinating that you can communicate with them, and that's legit a piece of software now. That's the beginning of an agentic system written in a paragraph style that my 12-year-old daughter could probably write.
Yeah.
Not to diss your code. I'm just saying that conceptually, a lot of the heart of this is accessible to many more people now. But you said something else interesting there. I want to double click because you said the structured output part of LangChain, that if one of these if-then statements gets executed, it's actually generating a piece of Python code as to what it should execute.
Kind of. So I have this Python structure. It's not code. It's actually a structure, which is just data. So technically speaking, it's not running arbitrary code on the back end. But what it's doing is maybe, for instance, I'm not sure exactly how it works, but for instance, maybe LangChain says, okay, we have this prompt that they gave us. Let's construct a prompt around it that tells the language model to output its response in a JSON format, for instance. right? And then the language model tries, sometimes it fails. So what's cool about LangChain is they've iterated over this approach over a lot of applications, and they've made probably a pretty complex prompt with examples and stuff like that of how the model should output in JSON. And then they take that JSON, which is still just text, and it might have like a curly bracket that's in the wrong spot, or there might be like, it might be missing a quote. So if you try to just simply evaluate it as JSON, it might break. So they also have a system for, once it outputs this textual structure, relatively consistently getting it back into a literal structure in Python where it's explicit key value pairs that you can then query with the correct data types. It's not just a big string that's pretending to be that.
All right. So language models are Oompa Loompa machines. You don't quite know exactly what they're doing, and they do things inconsistently. And LangChain says, well, we're going to help you solve that problem by forcing it through clever prompting and maybe even chain of thought prompting through a sequence of prompts to answer in a very discrete way that you as an engineer can use consistently.
Yeah, and that's a huge amount of LangChain tooling is just parsing. Like if it breaks, you can have reprompting techniques. So if it breaks, it just goes around a few times to try to coax the correct output. Yeah, so I'm just using the most naive approach, but it's actually very effective in this application.
Okay, what's next? Let's see it.
Cool. All right, so got the slides. So we've turned our query into a plan of action. So, and this plan of action is defined based on us. And I will briefly note, it's really crazy to do this human verbal coding while simultaneously doing the actual coding and getting them to play nicely with each other, which we'll kind of see the ramifications of that maybe later.
Okay.
So, oh, actually, we'll see it right now. So we have the plan of action. And you might recall previously, I was like, I want there to be a verbal response as soon as possible so that the user isn't just sitting around waiting for everything to happen, all this querying of LLMs. I want as quickly as possible for there to be a response that's small, happens in a relatively snappy way. And then I want to execute actions later. So that kind of implies there's an implication there. So if I ask the user, hey, can you describe what protocol I should follow when shipping LTL? What I'm doing here is I'm providing a verbal response before I've done all of the major processing like RAG, querying the LLM, all that stuff. I'm trying to provide a response before all that stuff happens. And then also after I get the retrieval, I want to actually answer the user's question.
Right.
So this is kind of difficult because now you really want the first response to be aware that there will be a second response, because you don't want the first response to not make sense when the second response happens. Okay. So here, what I ended up doing was I take the plan of the action, I use this LangChain structured output to create a textual response, and then I use that to generate audio. But at the same time, I'm also deciding if there should be a follow-up question or if there should be a follow-up response. So I'm telling the language model, you will get information after you execute this action. Do you think, based on this user's question, there should be a follow-up textual verbal answer? And by having it make this decision here, it simultaneously decides, should there be a follow-up verbal response? Which is optional. If you just say, hey, pull up this document, there doesn't need to be a follow-up response. But if you have a question, there might need to be a follow-up response after you get information from the document. So I'm making that decision, but also kind of naturally, because the model knows that decision has to be made, it also informs the sort of preliminary response that it gives. And it tries not to give too much information, and it formats that with the knowledge that there will be a follow-up response later.
So user asks a question, you do this plan of action, you try to figure out what should happen next, and then you essentially do two things in parallel, it sounds like. On the one hand, you ask the language model, hey, buy me some time. Just say something half smart about what we're going to do here for the user, while you call also the same language model, but in a different thread, essentially, and ask it to decide actually what to do and how to do it.
Yeah, and that's kind of what I intended, but it is kind of crazy. Like, once I asked it a question that it didn't need RAG for, like it just knew because it's a parameterized model with knowledge. So it decided non-determ, I don't need to pull up a figure. And in the initial verbal response, it just answered my question. and it decided that no follow-up was necessary. So when you're using, this happens a lot, when you're using these language models in complex, you're just saying, can you just parse this out for me? You're also relying on its implicit parameterized knowledge. So you can get back really interesting responses that you didn't explicitly define, but often are actually very nice, which is kind of cool.
Yeah, the magical serendipity of playing with language models, which sometimes feels wonderful and sometimes is deeply frustrating.
Yeah, and if you were like, it has to have a response, then you can like kind of program that in. You know, it kind of depends on your use case.
For sure.
All right, so
what's the next piece of this puzzle?
We did it. So we
have
it's
literally sort of conceptually that simple.
So we have this plan of action and we have an audio response. Also, we've saved if there should be a follow-up audio response later. So we have basically everything we need for the first response, which is just the audio response. We haven't actually executed any of the operations that we think will be necessary. We just have, hey, I will find that figure for you, right? So we send that back to the front end. And there's a billion ways you could do this. This is how I chose to do it. The back end is what's called stateless. So it doesn't have to remember things. It just does stuff based on calls. So the way I'm doing this is I send this entire packet with the plan of action and the audio to the front end. Then in parallel, the front end plays the audio, and then it sends the plan of action straight back to the back end at the same time in parallel. And what the end result is the audio starts playing, and then you trigger the execution of the plan of action while the audio is playing.
Makes sense. This is still part of the buy me time protocol here.
Yes. Yeah. Which is the reality of a lot of these. Like if you're trying to build like a verbal thing, there's also like maybe more rigid sort of development things you could do. I think there's Whisper has like a streaming mode. I know OpenAI has some more complex audio systems. Also, kind of in the background of all this, I'm using OpenAI to generate all this stuff. I could be using Grok, which has a token output that is like an order of magnitude faster. So that would also drastically speed up things. There's a million ways you could try to buy time without the exact approach that I took. And you can kind of mix and match them at your leisure. But yeah.
Very cool. This is great. Okay, is there more to this application?
Oh yeah, there's a ton. Yeah, this might be kind of a long one, but we're getting to the fun stuff now. So we've bought time, we have a plan of action. Now we're going to send the plan of action back to the Flask app. And this is when it's just kind of code, right? We've done a lot of our AI stuff. We've decided the plan of action. So now we just have to execute the action. And I have two of the same. Cool. So we have to execute the action. Some of these don't require much. Some of these might be scroll up, scroll down. They might be zoom in, zoom out. They might be hide, whatever your application has. You might not require any AI. So the second step might happen very quickly. Some of them, so for instance, if I say, hey, can you pull up the portfolio overlap of the S&P 500, it might decide that a figure is required and a follow-up verbal sort of response is required. And if that's the case, I chose to define this as two separate functions. So we have, now we're using RAG. We're actually using our RAG tool to find documents that are relevant to the query. So
now we're doing a RAG search with GroundX.
Yes. So I have two abstractions for this. I have find figure and I have find PDF, I believe. It's kind of small on my screen, but I can find a figure or I can find a document. And these are virtually identical, except one finds a page number that it thinks is the figure that is relevant, where one just pulls up the URL of the document without snapping to a specific page. So I wanted to briefly, for those of you who don't know, what is GroundX and how is it working? So when you have a PDF, like one we just explored, you upload it.
Not just a PDF, but we're good with PDFs.
Yeah, but we're good with PDFs. Yeah. When you upload a document, it might be a PDF, it might be many other formats, but when you a PDF, for instance, it uses a fine-tuned vision model to look at your document and break it up into sections, and then break down those sections into a textual format. So for instance, the diagram might be represented in a JSON format that represents its kind of implicit structure and all of its core ideas, but in something that a language model can understand that's not like this dense visual representation. Now, it does create many textual formats that are relevant for many applications. We're just looking at a small subsection of what we call a semantic object that is used to describe the document.
Okay, so this is part of the interesting magic sauce, I guess, of GroundX here, where to build any application, typically complex documents go in, and then interesting AI comes out the other side. And we've really built this state of the art. I don't think anything's close right now. Ingestion engine that can take apart these complex documents, especially with figures and tables, which typically cause downstream hallucination with RAG applications. And as you can see here, turn that flowchart into pretty clean JSON that, I mean, if you had the full thing here, you would see it actually gives you a narrative description of what this chart is about. It's not just the key pairs that are inside the chart, which then enables you downstream to have really accurate RAG search and thus very accurate RAG completions when you send it to a large language model at the end of this pipeline. So this is quite a magic trick. And I guess what you're seeing on the top here, those boxes being drawn, that's automatically happening by our vision model. That's not Daniel making graphics for this video. That's our vision model identifying where's the text block, where's the table, where's the flowchart graphic in this case, literally bounding box it. And if you do RAG search here, you literally get, and if these would come back as retrievals, you would get not just the textual representation of those retrievals, you get literally the multimedia object and the page number in the document, and literally the bounding box of where it was on that page, which is really cool, I think, for different kinds of GUIs that are just, we haven't even really fully explored yet. Yeah,
and that's kind of where we kind of come in, right? So most of the time, the way this works is you upload a document to GroundX, and basically any RAG system. The common idea is you upload a document to GroundX, gets turned into like this sort of queryable textual thing. And then you put a query, you get back the textual thing, and then you just use that as a context to do retrieval augmented generation. You take that text, you use as a context, you put the query on top, then you pass that to a language model that generates an answer. But what's kind of cool about this sort of visual sort of extraction system is when you upload a document, the semantic objects are tied to bounding boxes in the document. Mm-hmm. So when you upload a document, you can then query those semantic objects. When you query a semantic object, you can, get back the textual response for a textual response or verbal response, but you can also use the bounding boxes that are part of the semantic object to find the original source figure within the PDF. Mm-hmm. And that's what we're using to say, hey, can you find this figure? That's how we're doing that. We're just grabbing the bounding box that is relevant to the user's query.
Yeah, and I think actually you also get the multimodal URL literally in the retrieval if it has a multimodal element, if it's a table or a figure.
Yes, yeah, you could as well. Instead of just rendering the PDF, you can just pop up an image as well.
Yeah, which is great. Okay, I mean, I love this because we've started to think about chatbots as black boxes where you ask it a question, it does some thinking, it searches some documents, it formulates an answer. Well, that kind of assumes the end medium should be a chatbot, but there's so much good information still in the original source material that that's feeding a RAG system. I don't think there's any reason for that material to disappear, as long as you have an AI in the middle that has a very smart way of getting at the little bits and chunks that actually matter to what you want to know about, which I think your demo here is really highlighting very nicely.
Yeah, it's like there's some things, like a picture sometimes speaks 1,000 words. Like there's in engineering, right? I can't tell you how many times in like when I was taking classes or when I was teaching, whatever, I like try to verbally explain something and I go, hold on. I grab a whiteboard and I explain it in 2 seconds and it clicks, right? Some information has to be visual. And as we explored, I think previously, when we were doing the open core, diffusion models are great, but they're not good at rendering a lot of types of visuals, like diagrams, for instance, that have complex relationships. Yep. So it's really nice to be able to leverage the really great figures that humans have made within this type of system. I completely agree.
Yeah, I mean, there's trillions of pages. Really, if I think about the great unskill philosophical, I think about the great unlock with generative AI. And there's trillions of high quality pages of information that humans have thought smart thoughts and encoded them into documents, essentially, for a long time now, multiple thousands of years. Obviously, the ones we're dealing with are mostly in the lab for RAG, but that would be a super cool RAG, I have to say. They're brilliant ideas and some shitty ones in complex documents. And now is this moment when GenAI can unlock that massive repository of human information across generations, just release that and build AI on top of that. That is super, super cool. That to me is like, that actually is the coolest part about RAG. That's the big unlock in my head about it. You know, it's, you could break it down to like, hey, it's like corporate document search and trying to find an answer to a question stored in a PDF. Yes, that is technically true. But the cool part is, what do those documents represent? Human knowledge stored over generations that now we can turn into, bring an AI to read them, understand them, and talk to us about them. That is super cool.
Yeah, I couldn't have said it better myself. I completely agree. So yeah, so all right, back to the slide. So
back to the show.
Yeah, I mean, in my opinion, that's the show. But back to like the reason we end up talking about that type of stuff.
Sure.
So we did it, right? So the way this actually ends up shaking out is you call GroundX, you get back these semantic objects. The semantic objects contain the URL of the PDF. It contains these bounding boxes, which we can use to find a page number that's relevant to your query. And then also, because it's RAG, we also take all of the semantic objects that we think are relevant, we stick it into one textual representation, which we call the search text. And we're also keeping track of that. And the reason we're keeping track of that is because next, there might need to be a verbal response. So if you recall way back when we—
By the way, let's go back to that slide for 1 second, because what you're looking at is not heavy duty code here. I mean, you're literally saying, return the source semantic object, give me the source URL, give me the boundary boxes, give me the page number, and now you can render that on the screen.
Yep.
So you can do a pretty complex visual GUI here with, just a line of code, really. It's very cool.
Yeah, and it's really the hardest part is just how do you choose to render PDFs on the front end? Like it's pretty straightforward. So if you recall, way back when we created the first verbal response, we also decided, should there be a follow-up response? And now that we've done RAG, because we decided that finding a figure was required, we now have this textual context which we can use to construct the secondary verbal response that answers questions based on the document that was found. So we just do that, right? This is classic retrieval augmented generation. You take the query that the user asked and this textual representation of relevant information, you stick them in a single prompt, then that's called augmentation. And then we're passing that to OpenAI to generate a response. But just to make things kosher, it's really nice to just wrap this in LangChain parsing, because if you ever need to add something or modify or tweak something, it's nice to have this little wrapper that allows you to construct explicit output. So then we do that. So now we've generated a textual response with RAG. We pass it to Whisper, which does text to speech now. And then we just save that audio. Then that can be, I had it zoomed in. Then that audio can be passed back to the front end along with whatever PDF was found or whatever page number, whatever. And that is used to generate the final response. And that's the demo.
Very, very cool, man. I love this. I love this demo. I love bringing in voice. I love bringing in multimodal interface. And I think you're moving where RAG is going to land. RAG is, to me, is not, even though we're a company that sells tools to do RAG, but RAG is not the end destination. RAG is an important, vital piece of the logic and the search and the intelligence and the document understanding of applications that do something else, that interact with you in some other way, that solve some problem. And I think as RAG becomes maybe less of a new discipline and more of a like, oh, this is just how we interact with language models and private data, you're going to start to see really, really creative and interesting use cases where RAG's in the back and Maybe rags in the, where's the party in the front? Business in the front.
Yeah. This is the front party in the back.
It goes, but one side is rag, and the party is, I guess, in this case, in the front end, letting people do really interesting things. And you don't have to think about the rag. Let the rag do its business and build great experiences for people.
I mean, it's like any technology, right? It's like the internet, right? Like someone was like, I have a server that runs a website, and then like I'm a webmaster, and everyone's like, hurrah! And then that becomes normal, and people go.
I'm old enough, by the way, to remember when the webmaster was kind of like the prompt engineer.
Yeah.
And he would show up at the party, and people go, "Wow, tell me about the web. How does it work? What does it do?" That guy had props for a while.
Yeah, I'm simultaneously very excited and very afraid. Not afraid, but currently I'm famous, right? I walk into a room of a bunch of nerds and they go, "You work on AI? Wow!" But
the time will come, young man, when no one will give a shit about your skill set.
I kind of hope it does, kind of, because once this thing becomes mature and we go, okay, cool, we don't just want to like look at this and like fanfare and like confetti, wow, look how cool it is, but we actually want to start using it for things that are good and useful and help people. That's, I think, where we're moving towards, and it's cool. The hype is declining, but I think the usability of AI is rapidly increasing.
Yeah, tell us again, old man, about how you worked with the first large language models. Why don't you just go back to Earth and let the cool kids chill on Mars with Elon, all right?
I've thought about it, man. I'm not excited for when I'm like
Emperor Elon, by the way.
So weird. I was born in 97, so I'm going to be like, when I'm really old, people can be like, you're born in the 1900s?
My daughter does that to me all the time.
I'm actually already getting it. I thought I'd have to like have kids or something, but no.
He's like, shut up, Dad. You're from the 1900s.
Like, yeah, what do you know?
Oh, my heart, because it's actually true. Oh.
Yeah,
it's terrible, but it's real. So I'm sorry you didn't make the cutoff, man.
I didn't.
All right. Well, thank you, everybody. That was a great episode. I feel like we learned a lot, and this is really cool. It feels like the future is being written in front of our eyes. So thank you for doing that with us today, Daniel. Everybody, I always save it for the end. It's supposed to be at the beginning. Like, subscribe, leave a comment. You'd think I know how to do this by now on YouTube. Anyway, thank everybody for joining us on Rag Masters. That's it for today. We'll do it all again next week with something else really cool. I promise you. Talk soon. Thanks, Daniel.